Good afternoon, everyone. Welcome. So first, by show of hands, who uses a web server? Nginx, something like this. Okay. Are you familiar with MTLS, TLS, PKI, all of that stuff? Okay. We're in good crowd. So this is our specialty. This is Caddy's specialty. I'm going to show you how to use Caddy to build your fintech infrastructure so it can reduce your headache and give you a solid foundation to build your business on it. First of all, let's introduce myself so you know who you're talking to and who's talking to you. I'm Mohammed Alsahaf. I'm one of the core contributors and core team members to the Caddy server. And this is basically taken a few days ago. So I'm not just a random person who's talking. I'm someone who's deeply familiar with the software, and I've been part of the team since 2019. I am the co-maintainer of some of the plugins and modules of Caddy. Chief amongst them, the Nginx adapter. So basically you give Caddy your Nginx configuration and it will run with Nginx configuration. And there are others. I have my own projects, and I've given a workshop on how to write a Caddy plugin before. And that would be my website if you scan the QR code. That's my website, caffeinatedwonders.com. So let's start. What is Caddy? Caddy is basically, it's a platform for Go applications, and it comes with configuration management, login management, and storage management, etc. It's an extensible web server in Go. However, at its core, and in it itself, it knows how to do four things. It knows how to do an administration through an administration endpoint. It knows how to do logging, structured logging, and it knows how to store data and retrieve data, and it knows how to load and configure apps. And one of the standard apps that comes with it is the HTTP server app. There are also two other apps that comes built in. That is the PKI app, Public Key Infrastructure app, and there is the TLS management app, which creates the certificates, distributes them, and manages the TLS connection for you. So this is basically what Caddy is. It comes with the TLS manager, PKI provider, and HTTP server, and everything else is pluggable. So you can have more apps in here, you can have more handlers or plugins that will come into the HTTP server or the TLS manager. So this is just the core of it, and this is the beginning of it. Caddy comes with much more inside of it. Let's explore. But the first thing that I will be asked, Sahaf or Mohammed, why Caddy? Well, what distinguishes us from everybody else is the default to security. You run Caddy, and the default is HTTPS, not the other way around. You start with TLS automatically. You tell me the domain, I start with TLS. And Caddy is classified as the best in class, and this is not our word. This is actually an academic paper that's published saying that everybody else should take lead of Caddy. Now, what comes with Caddy? It has smart request matching and advanced reverse proxy capabilities, dynamic upstreams, load balancing, active passive health checks, circuit breakers, and NTLM transport. The NTLM transport is actually a paid feature with our competitors, but in Caddy it comes in as an open source plugin that you just build into. And you can also configure Caddy dynamically on the fly without dropping any connections at all. So, we go back. What is Caddy and how does Caddy work? First, I said that Caddy comes with automatic HTTPS, and that is done through the ACME protocol, Automated Certificate Management Environment Protocol, and it is part of the TLS Manager app here. And then the connections are passed from the TLS Manager to the HTTP server over here. And if we're gonna run the features comparison one by one, you'll see that we check all the boxes all the way down the middle, yet our competitors are not even close. And this is not really a biased review. This is actually objective. So you can see we do have the basic HTTP server functionality, but we offer much more. We come with automatic HTTPS. The other web servers, they require an external tooling that is kind of brittle when it comes to managing the certificates. You run Caddy and it will fetch the certificate and it will start renewing them 2/3 of the way through. The certificate comes with 3 months lifetime, and 1 month before expiry, Caddy will try to renew it, and then if it fails, it will try 2/3 of the way through, and so on. We have active health checks, which means Caddy will make a request to your upstream checking if it's alive or not, but there is also passive health checks, which means Caddy will not make a real connection to your upstream. Caddy will actually just check the request as they're flowing back and forth, and if it's failing, it will mark the upstream as down, and it will go to the next one. And we have multiple load balancing strategies, so Caddy comes in with round robin, least connection, IP hash, etc. Also, one of the features that are coming with Caddy by default in the standard distribution is automatic or dynamic upstreams discovery. We can use DNS, you can use SRV records, you can use A records, AAA records. All of those are resolved dynamically at the time of the request with cache. On the other side, on the competitor side, this is only resolved during the booting time, and then the same IP address is used throughout the request lifetime, throughout the process lifetime until you reload or restart the process. Now, the killer feature of them all is cluster coordination. You cannot live with one server in your environment. You have to have multiple. And if you have multiple servers, you need to have them coordinating their data. For example, you have your certificates, you have your TLS certificates. You cannot have duplicates across your nodes. That is not really efficient, and it creates a load on the certificate authority. So what you can do with Caddy is you configure Caddy with a shared storage. For example, SQL server, you can store the certificates in a SQL server, and all the nodes you have that are running Caddy will be reusing the same certificates from the same shared storage. And if you're, for example, using the rate limiter that's built by the lead author of Caddy, it will also use the same distributed storage or the shared storage, which means if the client hits any of the nodes in your environment, they will see the same rate limit that it's hit. So if the client hits the rate limit in one node, and then they are redirected to another node, the other node will not let them pass because the same rate limit reading is seen on the other side. Next, we have the config API. What does that allow us to do? With the configuration API, it allows you to configure Caddy dynamically on the fly to patch certain parts of the configuration. Say you are managing or serving multiple domain names or multiple hosts on the same Caddy instance. Now, you want to change the configuration for only a subset, one of them, not to reload the entire thing. You can direct the configuration change to that particular subset of the configuration. I'm going to hit that later. I'll show you how. And it allows you to include additional clients. If you're serving SaaS with custom domain names for your clients, this allows you to add more domains as you go on without having to incur downtime by having to reload the server. You do not reload or restart the server. It will just take the new configuration. It will not have any dropped connections at all. Lastly, and the most important of them all, Caddy is memory safe. The other web servers are written in C. C is not memory safe. C could bring in out-of-band reads. C could bring in memory corruption, etc. Now, Go is a memory managed language, and it will ensure that a whole class of memory vulnerabilities are taken outside of your concern. And keep in mind that Chrome, the Google Chrome team and Microsoft had published research saying that 70% of the defects or the bugs they have are memory bugs. So we're just, by using Go, we're eliminating 70% of the possible defects that could hit your software or your infrastructure. So what did we improve or bring into the environment. Caddy's TLS management will manage revocation for you. So if your certificate authority, for whatever reason, revoked the certificate for probably the private key was leaked, or they had misissued some of the certificates, and they revoke it, Caddy will replace that certificate automatically without you having to get involved into replacing it. More, Caddy can do OCSP stapling, which means even if the certificate is revoked, the certificate is still valid for a week. And by published academic paper, Caddy is the best in class when it comes to managing OCSP stapling. And what Caddy does is it will get the certificate status from the certificate authority, and sending this status with the response that's sent to the browser, and the browser will take Caddy at its word because this certification status is supplied with the certificate. And CA outages, let's say that you are using one certificate authority. Most of people who are using CertBot will be using Let's Encrypt only. What if Let's Encrypt environment, for whatever reason, is down? Caddy can protect you from that because you can configure Caddy with multiple certificate authorities, and it will skip to the next one if the first one fails and keeps going. So if Let's Encrypt, for whatever reason, they had their environment down, Caddy can go to the next one. And case in point, on my own servers, I definitely use Caddy, and Caddy uses by default two certificate authorities, Let's Encrypt and 0SSL. And at one point in time, Let's Encrypt failed to renew my own certificates, and Caddy switched them to 0SSL automatically. I only learned by the failure of Let's Encrypt when I received an email from Let's Encrypt saying that my certificate will be expired. I checked my server, and what happened is Caddy noticed the failure and procured a certificate from 0SSL when Let's Encrypt was down, which means now you have high availability, robust environment or web server for yourself. Now, and one of the most loved features of Caddy is the on-demand certificate or the on-demand TLS. Say you are a marketplace platform, and you want to offer your customers the ability to host their e-commerce store on your servers, but they want to use their own domains, and you didn't know those domain names in advance. And what you can do, you can configure Caddy with on-demand TLS, and Caddy, what happens is when it receives a new request for a domain name it has not seen before, Caddy will hold the request on the fly. It will ask an endpoint that you will configure Caddy with. It will say, Caddy will ask your endpoint, here is the domain name that I have received. I've never seen this domain name before. Am I allowed to get a certificate for this domain name? If you respond with anything that's 200, Caddy will get a certificate automatically and serve it back to the client. The only thing the client will see is a slow request on the very first connection, and then Caddy will manage the renewals automatically afterwards. This is used by multiple of our users, chief amongst them a platform called Dukan, and Framer, which is a website builder platform. We also have rate limiting, as I spoke earlier, that the rate limiter is developed by the chief developer or the lead developer of Caddy. His name is Matthew Holt, and this rate limiter will automatically balance across all the Caddy nodes you have. Moreover, it will protect your certificate authority from being hammered with multiple requests. So if you have 2,000 domains that you are managing, Caddy and Caddy has to renew all of them or get certificates for all of them. It will not do it all at once, getting your certificate authority to ban you. It will hold back, send a few requests, hold back, send the next, and so on. If there is failure at any of them, Caddy will start implementing the exponential back-off strategy. So if there is a failure, it will wait for I don't remember the number from the top of my head, but let's say 10 seconds. And if it fails again, Caddy will wait for 20 seconds, fails again, 40 seconds, until it gets a successful, and then it resets the timer. Lastly, we have the fleet coordination. And as I said, as long as you have a shared backing storage between all the Caddy nodes, SQL Server, S3, between all of them, NFS, Caddy will manage to share this data between all the other nodes as long as you have a proper locking mechanism, which SQL servers provide, and Redis as well. So, what did we get by using Caddy? You get rate limiting, you get validation of your configuration before it runs. Let's say you are running Caddy and you need to reload new configuration into Caddy. You tell Caddy, reload the configuration file, and the configuration is invalid for some reason. You misspelled one of the directives. It will not take your server down. Caddy will roll back to the last working configuration, and it will give you an error message saying, hey, the last configuration you gave me has an error in it. I'm still working fine. Fix the file and send it back. You get handling verification properly. You get robust environment or robust server against outages. You can manage your custom server, your customer domains. You get OCSP stabling, and you get protection against misconfigured storage. What that basically means, if you run Caddy to serve some website, it will try to get a certificate and has to store it somewhere. One of the first things Caddy will do is to check if it can write to the storage backend before it actually does anything. And this is to protect you from losing the certificates later. So if your storage backend is not writable, Caddy will refuse to run, asking to fix the storage backend. Maybe it's a permission issue, maybe it's a credential issue. Fix it, and then you can run Caddy. And this protects you from failures down the road. You get dynamic updates to the configuration file, and you can scale to millions of certs. And this is not just a claim without evidence. We have users who are using millions of certs. So, Caddy comes in with one of the most powerful routing techniques or strategies that I've seen. You can use any of these and more to route your traffic to a particular handler of the HTTP request. If you wanted to check if there is a file that exists or not before handling the request, you can use the file matcher. You can check against a particular header's value or presence to route the traffic a certain way. If the header of the authorization is available, the user is allowed. If it's not available, you send it to some different page. You can check against the host, which is the domain name, method, the HTTP method, if it's patch, if it's options, you know CORS. CORS is a pain. CORS, Caddy can handle CORS for you just fine. You just tell it that if it's options, respond with these headers. Caddy will manage it just as easily. Path regular expressions. Protocol, is it HTTP, is it HTTPS, is it something else? Query parameters, does the query parameter exist or not, what's the value of it, etc. Remote IP, vars, which are basically placeholders of whatever is inside the request. Vars regular expressions, not to negate, so you can have the Boolean expressions available. And expressions. Expression is really neat feature. It's a language that's a non-Turing complete language called Common Expression Language. If you used Firebase, it's the ACL language that's used on Firebase. And what it allows you to do is you can have some kind of a script that will tell Caddy, is this request allowed to pass through a certain handler or not? And can be as complex as you want it when it comes to Boolean logic. So with all of this, it allows you to shape your traffic, route it one way or another, and match it to however you want it to be handled in a way that's unparalleled by anybody else. And the handlers can also have some kind of a mutual exclusion logic. So if in a chain of handlers you have one handler that has run, and it has the same group as another handler set, the other handler set will not run because only one group is allowed to run if it has the same group name. And this is advanced configuration. I've seen it only once or twice. I use it for one particular use case where I want to route some client traffic to a particular route, but not to the others. And it's used in our translation of our configuration file, which I'm gonna come to later. So Caddy comes with all of these features. And by the way, one of the things that comes with Caddy by default, and Caddy was the first one to implement it, is HTTP 3 automatically. You don't need to do any advanced configuration. You don't need to do any additional stuff. Caddy will serve HTTP traffic automatically for you. And it was marked experimental back when the IETF RFC was still in draft. And once it was marked as final, we've graduated the feature from experimental to stable. So we come with structured logging, and we have observability. You can have metrics, tracing, an Acme server, which means the same mechanism that's used to get certificates from the certificate authorities by Caddy. Caddy can also give other certificates that are issued by Caddy itself, which means you can use it to serve certificates for your environment, which means, and I will come to this later, you can have a full environment that has TLS everywhere, no unencrypted traffic, no plain text traffic is running through an environment by using the Acme server and automatic MTLS management. And of course, as I said earlier, Caddy comes with a configuration adapter, which means the configuration format does not have to be the native format, which is JSON, or our own proprietary format, that's the Caddy file. You can use any configuration format as long as there is an adapter for it. So there is one that's the Nginx adapter, which you give it Nginx configuration and Caddy will run with it. There is a YAML adapter, you give it a YAML file and it will run with it. There is a Q adapter, you give it a Q configuration file and it will run with it, and so on. Caddy comes natively with the Caddy file, and we'll see an example of it later. And there is the native configuration language, which is JSON, to allow the programmable updates and dynamic updates of the configuration. And this is an example of our config file, and to be compared against our competitor. So this will serve a website on port 8080 and will reverse proxy to a localhost 8081. It's technically 2 lines. The equivalent on the other side is 4, 5, 6, 7, 8, 9, 10, 11, 13 lines. Now, this will serve plain HTTP because there is no domain name defined in the configuration file. We go next. By the virtue of having a domain name in the configuration file, Caddy comes with automatic TLS, HTTPS for your website. And this will keep your certificates automatically renewed without any additional effort or work or additional tooling on the other side. However, we see on the other side, you will have something similar when it comes to the earlier plain text configuration, but you also have to configure certbot externally, which if it fails for whatever reason, it will not have robust error handling. So compare this to this, and this is much less of a headache than the other one. Now, everybody's complaint or concern is going to be benchmark. Are you fast enough? You're not written in C. How can you be so fast? You cannot be fast. You're written in Go. Actually, when it comes to benchmarking, we have seen benchmarks that show Caddy when it comes to unencrypted single TCP. Let me move to the other side so you can see it. We meet Nginx when it comes to 23.4 gigabits for the unencrypted download. So we are on par with the competitor. When it comes to encrypted connectivity, even a single TCP connection, yes, we lag behind. However, with multiple TCP connections, we are on par with the C web server, which means you will not be losing any speed when it comes to using Caddy. Keep in mind, the delay that any user will experience, it will rarely be coming from the web server. the bottleneck is almost always the application server, your SQL database, and then the business logic. The web server is just sending bytes back and forth. It will not cause any delay. And even if there is a delay, it's negligible compared to the bigger time consumer, which is the app logic. Now, what's interesting is the difference in failure mode between how Caddy handles it versus the others. For Caddy, if there is a high traffic, more than it cannot handle, Caddy will not fail, Caddy will not error, Caddy will just be a little bit slower. So your client will just see slowness in response when it comes to handling high traffic. On the other hand, the handling or the failure mode of the high traffic in the competitor is throwing out errors. It will just refuse to actually serve the connection. And consider this when you want to talk about the user experience or your customer experience as they're using your application or website. Do you want them to just see slowness, but you're still up, you're still running, you're still serving business? Or do you want to just fail, give up, and I don't know how to do this. Sorry, I'm too tired for this. This is not really the optimal user experience that you want to give to your customers. So we're really offering a robust solution that is the optimal kind of experience that can be had in a fintech. You need to have a software that will not let you down the road. And this is what we have. But I have to tell you, or you have to tell me, or you will tell me that I have needs and you have not crossed them out yet. How are you so sure that you can meet my needs? And I know your needs. This. You have three concerns. You have security concerns, you have scalability concerns, and you have the user experience or the developer experience concerns. When it comes to security, we offer automatic HTTPS. We offer native MTLS, which means when you're integrating with some external party, I know, for example, from my experience, Visa and MasterCard use MTLS extensively when they connect to clients or the other way around. And I've seen certificate connectivity errors more than anybody would like to see in their lifetime, which is zero. You don't want to see any certificate connectivity errors. Caddy can manage this for you. It can get or manage the public key infrastructure for you. It will generate the root key, private key for you. And from there, it will start having the intermediate and the leaf certs. And there's more. The reverse proxy handler in Caddy can get its own TLS certificate for MTLS and keep it renewed through the lifetime of the connection. Which means even if you get a certificate that's 10 hours long or 1 hour validity, Caddy will be able to renew it again and again and again, which means you can improve the security by decreasing the certificate lifetime and automating the entire workflow. And again, on the terms of security, we have memory safety, and this is I'm going to come to later, which Caddy enables you to have zero trust infrastructure in your environment. And when it comes to fintechs, you need the zero trust infrastructure. You cannot just trust any software or traffic that's running through your network just because it's inside your network. You need to trust that it's allowed to actually be in your network. And Caddy enables this by, again, back to the TLS management and the PKI provider. Next, in your needs, when it comes to your fintech needs, you have scalability. You want to actually be able to run clusters, which Caddy can manage the clusters by having shared storage. Point Caddy to an SQL server as a shared storage, and you can have sharding on your database, and 10 Caddy nodes or more, all of them will be cooperating with each other to handle the traffic. You can have zero downtime deployments. When you reload Caddy's configuration, Caddy will not drop any connection. There will be a brief point in time where there are two configurations running, the old one and the new one. Any new connection will be routed to the new configuration, which you've loaded. Any existing connection will still be running against the old configuration, which means you can have no downtime at all, even if you change the configuration of your website. There's more. You can have zero downtime deployment of your upstream app with reverse proxy without actually having any 502s as responses. And I'm going to show you how later. I have this in my slides. Dynamic configuration, we've already spoken about this. So Caddy offers a configuration API, and the configuration API has an admin endpoint. By default, it's localhost on port 2019. You can query the config, the current running configuration. You can send additional configuration to change it. You can patch certain locations of the configuration, and so on. And there is more to the dynamic config, which again, I'm going to come to later. There's a lot to talk about. I hope you have enough energy to listen to all of that. Finally, when it comes to the user experience, the Caddy file, which you've seen earlier, the 2 lines versus the 13 lines, is often praised by so many users. Users have a pain of managing those tens of thousands of lines, well, not going to be thousands, but hundreds of lines of configuration files for their web server. And the headache of managing the additional lines of code, they are technically code, is not really something, it's like the death of 1,000 paper cuts. So the experience of having the nice format of the Caddy file is one of the features that are often praised by our users. The config API comes again, it comes in multiple places. We have structured logs. So this means that the logs are actually queryable, and you can build dashboards out of the login content. It will have all kinds of aspects about the connection and the requests that have come through and back. And it allows you to actually inspect the variations in the data as it flows through. For example, if you want to count the number of 404 responses or 502 responses in the lifetime of the process or for the last 1 week, the fact that our logs, the native or the default format is JSON, means you can have it pushed into any tool, Loki, Grafana's Loki, for example, and you can then do some analysis on it to come up with an actual value or knowledge out of that. Also, as I said earlier, we have great observability features. We have metrics, Prometheus metrics by default or built into Caddy. It's not enabled by default because metrics tracking comes with actual performance hit because you have to keep the counters going. So it has to be opt-in, but the feature is there. And we have tracing available in Caddy, which allows you to track the request as it passes through the different handlers and the different nodes that goes through your traffic, and so on. So let's go through some of the claims that I've made earlier. I claimed that Caddy is a zero-trust infrastructure enabler. And it wasn't just a claim without evidence to back it. I've done this experiment myself a few months ago, actually back in February. I developed in Terraform, a set of Terraform files, an entire infrastructure where I had multiple Caddy nodes. All the connectivity between all the nodes is with MTLS in between, so no external entity can just randomly connect to my servers without actually being allowed from within the infrastructure itself. It will have TLS everywhere. I have an Acme server internally to give certificates to my nodes, and there is a shared storage, which is I use PostgreSQL. Yeah. So if you scan the barcode, it's gonna the QR code. It's gonna take you to the blog post here. It will take you through the detailed description and a walkthrough of how to actually implement. How to actually implement zero trust infrastructure using Caddy only. And I try to keep it as traceable as possible or as trackable as possible for the beginner user so they can get a hands on how to actually develop this in Caddy for their own infrastructure. And this actually allows you or enables you to get your InfoSec certification, PCI DSS, and so on, easily because all my traffic is encrypted. There is nothing that allows an external party from a man in the middle. And this is here how it's built. So the infrastructure that I've built comes in with, it actually starts with 3 servers. I have an Acme PKI server, and the certificates are shared between the nodes. I have a dummy upstream app, which I reverse proxy to, and the connectivity from the edge internet-facing server to the app server uses MTLS in between. And those MTLS certificates are procured from my own Acme PKI provider, which means no external party can get a certificate that would allow them to get into my traffic. And what this allows you to do is, even if you expose your upstream apps to the internet, no external party who's in the internet will be able to get the information from here. It allows you to simplify your infrastructure a bit, although not kind of recommended. I have distributed data storage, so I have an SQL server for the data that's shared between all of these, and this means the certificates are shareable, are shared between these nodes, and as the traffic increases, and as you increase the number of nodes on the edge, it does not mean that you will have duplicate certificates. You'll have one set of certificates, all of them are shared on the SQL server, and it will scale as long as your database is scalable. And lastly, as I said, any concern of man in the middle, it's gone. You don't have to think about it anymore. And I have not used anything external besides the plugin for the Postgres storage. Everything else comes in built in Caddy. The PKI provider comes with an Acme server. The TLS, MTLS management, it comes in standard Caddy distribution. The HTTP server and the Acme server handlers, which connects back to the PKI infrastructure or PKI app that we have. When it comes to distributed storage, the most favored storage backing, from what I've seen from the users, they like to use Redis. I used Postgres because it's there. I like Postgres. The next case study to prove the claims that I've shown earlier. Caddy allows you to have separation of duty and remote administration. What does that mouthful mean? Let's assume you have multiple teams. If you have 3 teams and each team is responsible for some domain name or some segment of your microservices infrastructure where they are not allowed to touch everything else, then you can give them autonomy to configure Caddy however they like without actually impacting everybody else. And this uses the feature that's only available in Caddy as far as I'm aware. If you go here, the blog post over there, it will walk you through, or not a blog, it's actually a wiki post in our forum. It will show you, it will walk you through how to implement this for your infrastructure. And basically what it does, you tell Caddy, I need a remote administration endpoint on domain name example admin.example.com. And Caddy will automatically get a certificate for that domain name. And only MTLS connections are allowed to connect to that endpoint, which means you can expose that endpoint to the internet, allowing your team who works remotely to update their Caddy configuration without having to actually SSH into the server and run a config reload from there. Moreover, you don't want them to mess it, so there is ACL or access control list on it, which means you can configure Caddy to allow this particular MTLS certificate on a particular subset of the configuration file within the administration API, the config administration API. And they're allowed, for example, to do only GET request or PUT request or POST request. So you can define the HTTP methods that are allowed. You can define the MTLS certificates that are allowed, and you can define the nesting within the configuration, the JSON configuration file, which they are allowed to traverse. So if you have nesting of 3 nestings deep inside JSON, you can restrict them to that nesting only. They cannot interfere with the others. And this means you can give every team autonomy over their microservice without having to worry or overload the sole system admin who will be managing Caddy. They can manage everything else. And this, again, this was done just with plain Caddy. I did not have to use any plugins for that. I used just 3 main features: the admin API, the PKI infrastructure, or the PKI app, and there is something called ID attribute that you place into the JSON file or the JSON configuration. So you can limit instead of having to tell your users, this is the path of the configuration that you have to traverse, you can assign them an ID, and as long as the config API path contains that ID, Caddy will automatically translate it to the expanded form of the JSON format. So they can have a nice user experience when it comes to configuring Caddy and pushing configs. If anybody needs to scan the QR code for later, I'm going to leave it for a second there. Now we come to my favorite features. And I've said before, there is the on-demand TLS, which will hold the connection on the fly for unknown domains, and it will allow you to have your customers have their own domains to still manage their app within your server, but you'll give them the nice experience of having their own domain names. And this enables marketplace platforms and payment gateways to allow the customers or the merchants to have their own store with their own domain name, yet it's still managed by you. And it allows your merchants to have their payment pages be managed within Caddy on your infrastructure, but they still have the domain name that is owned by the merchant, which allows the branding to not be lost in the process of the payment. And as I said, this allows multiple businesses to run. This is one of the happy users that we had who's using the on-demand TLS heavily. And next, or the other feature that I love, you can deploy your backend app with 0 downtime. And I'm not talking about Caddy, I'm talking about the backend upstream of your application server, by merely adding these lines in your reverse proxy configuration. And what this does, when Caddy receives a request and it tries to connect to your upstream app, if it fails to connect, it will not respond with 502 directly. It will keep trying for 30 seconds with 1 second intervals, which means you can give your backend app, your upstream app, 30 seconds to go down and come back up without any downtime. And if you know Simon Wilson, he is the author of Django, the Python framework. He is the one who tried to implement this feature for his own blog. He was referring to a blog post by eBay, and Matthew Holt, the lead developer of Caddy, told him that you can do it by just 2 lines, additional lines in your configuration. And this is actually a seldom used feature. I have not seen users use it, even though it's wonderful. You can have 0 downtime in your infrastructure, and you cannot afford downtime at all if you're a fintech, an e-commerce platform, or any kind of critical business that's running, banks. Okay. You've been talking about Caddy for the last, 30 minutes or more. Who are you? Who uses you? You have no name. We know the other names, the competitors. We don't know who Caddy is. We don't know who uses Caddy. Caddy is actually used by Stripe, the Internet Archive, Dukan, and Mercedes-Benz, Framer, and there are others that I cannot talk about. And I'm sure at least these 3 names are not nobody. Mercedes-Benz are also using Caddy internally. the Internet Archive serves their websites using Caddy. But again, who uses Caddy? You're mentioning big names, global names. Maybe I'm not big enough for Caddy. Or maybe they're using it because they have a fan in there, but it's not really worth it. I'm going to refer to local names who are using Caddy, and they're very happy with it. They're here. We have Zed are using Caddy, and Muyassar is also using Caddy. I'm going to mention their use cases shortly. And we can all agree these are not small names. These are big names in the local market. First, the Zed experience. I connected with Hussam Marzouk, the lead engineer at Zed, in last year, July 2023, to talk with him about Caddy. And I showed him the feature, we discussed, and he told me that they're actually considering improving their load balancer or proxying environment, etc., or reverse proxy. And he said he'll consider it, he'll take it with their DevOps team and come back to me. There were 4 months of silence, and I was anxious what's going on. But in December, Hussam comes back and saying, Caddy is already deployed in production, and it's been doing well to the extent that it protected us from a DDoS attack before Cloudflare woke up and realized we have a DDoS attack. And that was news to me. I didn't realize that it's already in production. But here's the thing. I was shocked that the Zed team developed their own plugins and deployed it, and without actually hitting any obstacles or coming back to me. I expected questions, but nothing. And this speaks of 2 things. The skills they have at the Zed team, and the validity of the developer experience when it comes to developing plugins for Caddy. And there's also one more thing. It speaks about the power of the open source software. Because Zed was allowed, because Caddy is open source, Zed was able to read Caddy's source code, learn the technical capabilities that it has, instead of just taking our words for it. And they trusted the technical implementation. And the nature of open source software allowed them to study the plugins that are available for Caddy and use that knowledge to build their own plugins and deploy it. Moreover, after December, the Zed team had a feedback loop with the Caddy team, where they were reporting their experience, and we were able to iterate on it, resolve some defects, some bugs, and lastly, and I love this very much, we had a long-awaited feature request in the Caddy issue tracker. We were concerned of the impact that it might entail if we implement this feature. Performance degradation or degraded user experience and so on. And because Caddy is open source, the Zed team, Hussam, implemented the feature, deployed it in their infrastructure, took some reading of the impact, and reported the patch of the feature request to us, along with their experience that it did not really impact the performance that much, which gave us confidence that, yes, the long-awaited feature is really worth the implementation, and we can push the feature into main Caddy. And back to the open source win, or the open nature of open source win that comes, we took Hussam's contribution and we iterated on it. We took some review points and iterated on the code, and it's supposed to be released in the next version that will be released in the coming months. If you read the blog post that's written by Hussam, it's really eye-opening when it comes to their experience. And you'll see that one of the great points they mentioned, or one of the gains they got from Caddy, They had one of the pages was taking 4 seconds, and they used the cache plugin of Caddy to reduce the loading time from 4 seconds to 0.6 seconds. That's almost tenfold a decrease in latency. So this experience really speaks to the power of Caddy, and it's not just a fan speaking, and it's just a biased person who's on the stage. We have received the feedback, and from having them locally allowed to actually get a human experience, one-to-one discussions on how we can improve further and iterate further. Next, we have Muyassar themselves are Caddy users. And this was completely by accident. I was connecting with Muyassar for some completely separate initiative, and I was looking at Ali Al-Hushayan's GitHub profile, the CTO of Muyassar, and I noticed he has one of his repositories has Caddy in it. They had a Caddy file, a Docker file, and a Caddy file, etc. Like, okay. So I messaged him, I was like, do you use Caddy? And he said, yeah, we use Caddy in Muyassar, we love it. Okay, that's great. That's completely surprising to me. And this is one of the pain points for us, is that we don't hear back from people. However, knowing this, it allowed us to, again, connect with the local users and get some feedback from them. And I had a long discussion with Ali, actually. It was like a 5-6 hours conversation with him about their experience, what they received from Caddy, why they love it, and what can we do further, and so on. And I learned from him that actually are using a third-party plugin to allow their employees to access some internal portals without having to have VPNs and what so on. They just using a plugin that will have an authentication page with multi-factor authentication and so on that connects to an authentication provider, an authorization provider, to protect some of their internal infrastructure. And there are other users that are kind of trade secrets, let's say. So, again, we have good names. It's not a tiny software, tiny project that we're just trying to gain traction. We have traction. We're just trying to introduce the local market to actually learn about this software. And it bothers me that the local community isn't really aware of a piece of software that will help them immensely to actually grow their business, simplify their lives, take some of the headaches away from them, and allows them to actually focus on the things that matters for their business, on their business logic, on their apps, instead of actually focusing on managing their infrastructure that would give them headaches. So the last thing I would say, I'm biased in here. Caddy is an open source software. I am an open source software maintainer, and this is actually my hobby. And I hate that the open source contribution or open source community here is not really nourished that much. We're not getting the contributions from the Saudi community into the open source culture. And I highlighted the Zed experience and the Muyassar experience and so on to showcase that because Caddy is open source and the users had confidence in it, they engaged in a dialogue, and not only were they able to request some bug fixes or features, they were actually able to contribute features back into the software they're using and benefit not only themselves, but everybody else who's using the software as well. And I hope that this will encourage the local market or the economy or the community to engage with open source and get the local business to support open source software, not just by using it, but by contributing back. Fixes, code, documentation, financial support, all of this enriches the community, enriches the ecosystem over as a whole, and it benefits everybody, so we grow all together, and it's just instead of just one who's growing bigger than everybody else can handle. And with that, I'll end. Thank you.